Your AI coding agent explores your codebase the way developers did 50 years ago. Search for a string, open a file, read it, repeat, and it pays for every single token it reads. This year, a tool that replaces that loop with a map crossed 32,000 stars on GitHub. In its own demo, 5 questions about a code base cost about 3,400 tokens with the map, against roughly 412,000 without it. That is the pitch, about 120 times cheaper in that one demo. But buried in the team's own paper is a more interesting, more honest number. The map made the agent slightly worse. 83% quality versus 92, cheaper and a little dumber. In the next few minutes, the grep loop, how you turn code into a map, and the fine print the stars don't show. First, watch an AI coding agent work on a repository it has never seen. It cannot hold your whole codebase in its head. Context windows are finite, and code is huge, so it explores. It searches for a string using grep, a tool from the 1970s. It opens the file that matched. It reads a few hundred lines. It follows an import, opens another file, and reads again. Every step pushes thousands of tokens through the model, and somebody pays for every one of them, in money and in the model's limited attention. For a single question, that loop can run dozens of times. To be fair, it works. Agents ship real code this way every day, but it is like exploring a city by walking into every building and reading the mail. Nobody hands the agent a map. And here's the thing about code. The meaning is not really in the files. It is in the connections between them. This function calls that one. This class inherits from that one. This service sends an HTTP request to that route. Change one function, and what breaks is its callers, and their callers rippling outward. That web is invisible to grep, because grep sees text one file at a time. Developers have known this for decades. It is why your editor can jump to a definition or find every reference in a click. Tools have been building structural maps of code since long before AI. The new question is simple. What if the agent got the map? That is what codebase-memory-mcp does. Step through it. First, it parses. A parser called treesitter reads the source. 66 languages supported when the paper was written, 158 today. On top of that sits a type resolution layer modeled on language servers, written from scratch for this tool. Then it builds the graph. Functions, classes, files, methods, and routes become nodes. The connections become edges, such as calls, imports, inherits, even HTTP links between services. The whole map lives in a single SQLite file on your machine. Then the interesting part. The agent gets tools. Over MCP, the Model Context Protocol, the open standard for plugging tools into AI models, it exposes 15 typed tools. Search the graph, trace a call path, map what a get diff will touch. Instead of grepping, the agent just asks. So what does the map buy? 2 sets of numbers, and they are very different, so keep them apart. The flashy set comes from the project's own demo. 5 structural questions about one code base. Roughly 3,400 tokens with the graph, about 412,000 with file-by-file exploration, around 120 times cheaper. 1 demo, 1 repository, measured by the team itself. The careful set comes from their paper, across 31 real repositories, about 10 times fewer tokens, roughly 1,000 per question instead of 10,000, and about half as many tool calls. 10x is the honest headline. And for an agent running hundreds of questions a day, 10x compounds fast. Now, the number that makes this story worth telling. The same paper measured answer quality. The old-fashioned agent reading real files 92%, the graph agent 83%. Read that again. The map made the agent cheaper and slightly worse. Why? Because the graph stores structure, not source. By design, it does not keep every line of code. So when a question needs the actual text, the full body of a function, or every last call site verbatim, the paper itself says the file reading agent keeps the advantage. Line-level code is exactly what the graph intentionally does not store. So the real trade on the table is about 9 points of quality for a 10x discount. And whether that trade is worth it depends entirely on the question you are asking. So when does the map win? Structural questions. Who calls this method? Ranked by importance. If I change this function, what breaks? Trace the path from this root handler down to the database. Where is the dead code nobody dares to delete? Questions like these are painful with grep, because the answer is scattered across dozens of files. In the graph, each one is a single query. There is even a tool that takes your get diff and maps the blast radius before you merge. And because the map is small and local, those answers cost hundreds of tokens, not hundreds of thousands. The obvious play is a hybrid. Ask the map for the structure, then read the real files for the lines that matter. If this idea feels familiar, it should. Developers have been indexing code for decades. Cod tags gave editors jump to definition back in the text terminal era. LSIF arrived around 2019. And in 2022, SourceGraph announced Skip, a whole code intelligence format for navigating massive code bases. The structural map of code is not new. What is new is the customer. Those indexes were built for editors, and for human navigation. This one is built for a language model's context budget, exposed over MCP so that any agent can plug it in, with one explicit goal. answer structural questions in hundreds of tokens instead of thousands. Old idea, new customer, and that shift, more than any single tool, is the thing worth watching. Before you install it, the fine print. The quality numbers come from the team's own paper, and it is a preprint, not peer-reviewed. The grading was done by the paper's first author, not blind, on a custom question set. So treat 83 and 92 as author reported. The 120x demo ran on one undisclosed repository against a grep baseline and independent write-up called unoptimized. The tool also moves fast. More than 30 releases in about 5 months, which means any number you hear, including in this video, can drift within weeks. And the deepest caveat is the one the paper itself admits. On pure answer quality, reading the real files still wins. This is a cost optimization with a quality cost. Real mechanism, real traction, and a young, self-reported evidence base. A strong signal, not a settled fact. Here is the idea to keep. An AI agent's scarcest resource is context. Every token it burns rediscovering the structure of your codebase is a token it cannot spend actually reasoning about your problem. So structure is moving out of the loop and into a map the agent can query. 3 things to watch from here. Agents that mix modes, the map for structure, the files for truth. Code indexes becoming standard agent equipment, the way they became standard editor equipment 20 years ago, and the evaluations growing up, blind grading, public benchmarks, independent replication. If you want to understand the systems underneath tools like this one, that is what this channel does. We build the intuition piece by piece. Subscribe and start with our free AI course. It takes you from the basics all the way up.